our final presenter of the day is Justin Williams, owner and CEO of Williams and White. Williams and White specializes in the development and production of automated tool sharpening and grinding machinery for the sawmill industry. Justin is a registered professional engineer holding a degree in electrical engineering with a minor in commerce and is passionate about robotics and automation. He will be discussing the applications for the industrial Internet of Things in the mill and share some details on Williams and White's newest product, SawSense, which offers real-time saw temperature feedback and control. The new technology allows mills to adjust guide lubrication as required based on real-time saw blade temperature analysis. So Justin, take it away.
Excellent. So I'm very excited. Maybe you were here last year at OPTISAW. I would have seen a similar presentation. But what I'm excited most about is that we took a lot of the feedback that we got from the presentation, and we've advanced the product further directly based on what we heard back last year, or last time that it was at OPTISAW, which was really closing the loop on an exciting product. We're doing digital sensors, and I'm going to get into it, but they're digital sensors within your saw guide, right in your saw box, that are real-time measuring temperature variations of the saw blades. And the feedback that we got was that that's great data, but if the loop isn't closed, how useful is it, or how practical is it in the sawmill? And so we've advanced the technology in that regard, and I'm going to be going over that today in my presentation. So as we look at sawmills and we talk about the smart sawmill, we're looking at the application of sensors throughout the mill to give better real-time data of the production process. And that could be in sawing, it could be in dry kilns, planers, material handling, and what have you. And the ability of PLCs, Internet of Things, to be able to harness that data is like it had never been before. And also just the ability of high processing speeds and processing powers are enabling us to do new applications that we weren't able to do in the past. So from our perspective, we're looking at the sawing performance and the exact temperature fluctuations that happen within a saw blade during its cutting performance. We have a system that is also designed for band saws, but in this presentation, I really look at the application of the circle saws. So if you have guided circle saws, it has been shown from specific research that was done by FP Innovations here in Canada, that when we get a variation of temperature between the rim and the eye of the saw blade, we get changes in the tension characteristics of the blade. Those changes result in sawing deviation. So you might get more unscheduled saw changes, you're going to get sawing deviation, so you're getting worse lumber performance coming out of your mill, and you're getting sawing issues, which are obviously causing problems to your bottom line. So what is IoT? This can be internal to a network. It can be cloud-based up to the internet, so that you can get real-time data to your cell phone. And this is really the electrification, the sensorification of industrial plants, and in this situation specifically to sawmills. So here is SawSense. This is again, the product has evolved and improved substantially since last time that I was at OPTISAW. But for people that weren't here at the last presentation, we're embedding sensors directly into saw guides. There's two styles. There's a bolt-on. That same style can be embedded directly into your saw guide. That is enabling us to obtain real-time data of the temperature of the blade during the cutting process. So you've got a sensor that is located near the eye of the saw and a sensor that is located near the rim of the saw. By measuring that temperature variation, we're able to directly understand the current mechanical characteristics of the saw blade during the cut. The unit has full rechargeable batteries, compliant sensors to stay in contact with the blade during motion, and it's all wireless communication back to a base station. As you can see here, this is an example where it would kind of be a bolt-on system to the guide. Again, they can be embedded. We've seen from the research that we've done a direct reduction in oil consumption within the mill. And traditionally what we were doing is we were just getting the data, and then the mill themselves was just kind of manually adjusting the flow to the guide lube system. The advancement that we've made is the closing of the loop, and I'll show you that in some future slides coming up. So people have been able to get higher chip quality, increased mill speeds, and especially the reduction in oil and water usage, because traditionally people are just really, they're just cranking up the cooling on the blades regardless of what the actual temperature or running temperature of the blades are within the cut. Our system enables you to have eyes on that you weren't able to have previously. So before, it might be that during a saw change, they're looking at the saw blades, they're physically kind of looking for discolorization, or they're just kind of monitoring the outfeed of the lumber and looking for deviation in the sawing straightness. But this enables you and your mill to preempt that, to be working in front of the challenges occurring. So again, it's because of that change of the temperature between the eye and the rim, causing the loss of tension within the blade. That's what's creating the flex and creating the deviation in the sawing. So you can see here specifically in these charts where what would come up. So we have two systems. We have a PLC integration that enables you to do the closing of the loop, because you can tie right into the PLC control system of your lube system. And then we also have PC integration. The PC integration of the system is what enables you to do the data analytics. So within the PC software, you're able to see your different sensors, configure them, determine which location, for example, what sensor is in your saw box, and then you're able to see the real-time output of that information from the sensors in a graphical format. The PLC integration enables us to then take that information and use it in an automation standpoint throughout your mill. You can see here rim and eye deviation at a certain time, and when you see the large deviations between the rim and the eye, you can tell that you have an issue within your saw blade. So the two systems, one being integrated directly into the guide, one being bolt-on, really just depends on your application. Of course, if it's bolt-on, it's less modification to your guides. Sometimes there may be clearance challenges within your saw box, so we need to really embed it within the guide body itself. But both are great systems. Again, this PLC integration is the leap forward that enables the closed loop element of the system, as well as mechanical hardware that we have designed, which automatically varies the inbound flow of your water flow to your guide lube system. So you guys may all recognize this. It's a saw guide lube system. We supply them. You can really get them from many suppliers, and you may have an existing system on your saw box. What we've developed is a mechanical valving system that integrates to our PLC control system that closes the overall loop of the guide lube system within your mill, which was not being done in the past. So traditionally, again, people would just sort of watch the performance of their saws, and then they would make adjustments. A lot of times, as we all know, being in the sawmill industry, it'd be, oh, we had a crash, maybe we didn't have enough lube, or oh, we've got burning saws, maybe we didn't have enough lube. Just open up the floodgates and put as much lubrication as you can. Creates a lot of waste, creates a lot of damage, because you get a lot of liquid going into your chip load, going onto your conveyor systems, so you get more bearing damage throughout your mill, and your maintenance costs go way up. This optimizes and can be exact set points of what temperature you want to be running at. And then our digital valving system will either increase or restrict the flow of lube going to your saw guide lubrication system, which is distributing to all of your bank of saws. The nice thing is that it's a bolt-on system. So it just bolts in front of any saw guide lube system that you might currently have. We'd have to look at the exact engineering on a case-by-case basis, but for the most part, it's a bolt-on system that can just drop into the line very quickly. And then we integrate it within the PLC, and away you go. So here it is, kind of just in a graphical format of, you've got your saw guides that have your sensors embedded and are enabling that monitoring of the cutting process. You're setting set points within the software of where you want to be running for optimum performance. And the nice thing is, we still have just the PC-based analytical data. So we're tracking over time, what is the sawing performance? You can take that data and relate it back to what your quality of lumber is, and start to do analytics on that in a quality direction as well. And then now with the PLC and the hardware of the valving system, we truly have eliminated the need for kind of the guesswork and the human interaction within your saw guide lube control system. And that goes right to your saws. That's going to result in higher sawing performance and better output of lumber in your mill. Really, that is the end of our presentation. It was a quick one because it's an enhancement on technology that we presented last OPTISAW. But I'm very happy to be able to present that it was directly the feedback from this group about the technology that led us to continuing the innovation. So thank you very much for your time. I appreciate it, and I'm open to questions. I know there was a number of questions when we first presented this because it was such a new technology. So left some time here to field some questions from the group.
Okay, thanks, Justin. It's interesting to hear that feedback led you guys to make those changes, and I'm sure everyone's happy to hear about those and excited to see what that does for their mills. So yeah, we've got a couple of questions here. So you mentioned that it can now be integrated with PLC system. Is that integration with any PLC system, or are there any limitations?
It's really any PLC. So far, we've done it with Allen Bradley and also with Mitsubishi, but our engineering team can really do it with whatever system that you have. And again, the change was previously we had done it all to a PC system, so all the analytics was there, but not having it going to the PLC system, which is still totally wireless, by the way. But having that wireless communication to the PLC enables for a lot of automation within the mill. And yeah, we can do any brand. It's not a problem. Okay,
awesome. So with a multi-saw situation, would you use sensors for each saw?
Really, the choice is the mill. People are predominantly going towards that. They're putting it in every saw. Yeah.
Okay. So in the temperature monitoring system, the image that you showed mentioned that you're using needle valves as opposed to ball valves. What exactly is the difference between those, and is that important at all?
I think it was we were using a ball valve instead of a needle valve.
Sorry.
And it is because sometimes the inbound water can have some contaminants, and it has been found that using the ball valve makes sure you don't get any jamming, and then you filter it. So it's just more reliable, much more reliable.
Okay. And so with this upgrade, are there a couple sawmills that have already installed them? What's the reaction been so far?
We're working with a mill right now. So far they're really liking it. We're at the very beginning of the PLC full closed loop integration, but so far the reactions have been great. We did show it for the first time down in Atlanta, which was an interesting show because of COVID, but there was a lot of interest, and we do have people that have used it with the PC system, and the knowledge has, just of even obtaining the analytics has been great. But yeah, people are very excited about the full closing of the loop.
Okay. And with the PLC integration, does that then save a lot of time for sawmills, saw filers when they're looking at saw deviation, things like that?
Well, it just reduces the guesswork. Right now, you can set it at a set point that you find is where we want the temperature of the blades to be running to get the best performance, and you're not wasting any lubrication, and you're not just flooding it all the time to try to keep the temperatures down. You're able to optimize it, so there's cost savings.
Okay, right. And you mentioned at the beginning of the presentation that you're mostly focusing on circle saws. Is it also going to be applied to band saws in the future? Are you working on that?
We have the PC-based system working at a bandsaw application in Sweden. They've been, again, very, very good results as far as getting the data analytics. It's a little bit different because on bandsaws, there's not the same amount of lubrication element as with a guided system. But even in that situation, we could at least tie to the PLC so that you could then do further optimization or even displays throughout the mill on the current mill wide system.
Okay. I think that's all the questions that we have so far, actually. So if anyone has any other questions for Justin, feel free to email. I know that he's happy to answer those. And I think that's going to be the end to the presentations today. So thanks, Justin, for taking the time for those questions and give that presentation.
Thank you very much.